Welcome to the DIY Honda Garage channel. This presentation covers the diagnostic trouble code DTC P0117 for the 2011 to 2017 Honda Odyssey, specifically addressing the ECT, Engine Coolant Temperature Sensor 1 circuit low voltage issue. The ECT sensor plays a crucial role in monitoring the engine's coolant temperature, which is vital for optimal engine performance and efficiency. When the DTC P0117 is triggered, it indicates that the ECT sensor 1 is sending readings that are either too low or erratically high, which may affect engine control functions such as fuel delivery and emission controls. Understanding this issue is important, not just for addressing the current error, but for ensuring the vehicle operates within designed parameters to prevent further engine complications. The objectives of this presentation will help you identify symptoms, potential causes, and detailed troubleshooting steps for resolving DTC P0117 efficiently. DTC P0117 pertains to the Engine Coolant Temperature ECT Sensor 1 circuit low voltage. The ECT sensor is critical for providing real-time data about the coolant temperature to the vehicle's Powertrain Control Module, PCM. This feedback is essential for the PCM to make adjustments for fuel injection, timing, and emission controls, thereby optimizing engine performance and efficiency. In the Honda Odyssey, ECT Sensor 1 is typically located near the engine's thermostat housing. If this sensor reports low voltage or erroneous high readings, it can lead to engine performance problems, including poor fuel economy and heightened emissions. Diagnosing this issue effectively will involve checking voltage readings and continuity, as outlined in the following troubleshooting steps. Several factors can lead to the activation of DTC P0117. A defective ECT sensor is often the first culprit, which could either provide incorrect readings or fail completely. Additionally, wiring issues such as frayed wires, shorts, or disconnected connectors could also trigger this DTC by leading to improper voltage signal transmission. A loose or corroded connector at the ECT sensor or the PCM could result in similar symptoms, as poor connections can create intermittent circuit failures. Furthermore, while rare, a malfunctioning PCM may not process the signals correctly from the ECT sensor. It's crucial to investigate each of these possibilities during troubleshooting to correctly identify and rectify the cause of the low voltage issue. The symptoms associated with DTC P0117 can vary, but are generally linked to engine cooling and performance. One primary symptom is engine overheating, which can occur if the ECT sensor fails to relay accurate temperature information, leading the PCM to make incorrect adjustments. Drivers may also notice poor fuel efficiency, as the engine management system may not optimize fuel delivery without reliable coolant temperature readings. The check engine light, CEL, illumination is another common symptom, alerting the driver to possible underlying issues. In some cases, a rough idle or engine stalling might occur, particularly when the engine coolant temperature varies significantly from normal operating conditions. Recognizing these symptoms early can prevent further damage to the engine and associated systems. The first step in troubleshooting DTC P0117 requires turning the ignition switch to the on position, which activates the vehicle's electrical systems. Following this, you will need to access the ECT Sensor 1 data using the HDS, Honda Diagnostics system. It is essential to determine if the readings from the ECT sensor are about 356 degrees Fahrenheit, 180 degrees Celsius or higher, or if the voltage is 0.08 volts or lower. If the readings fall within these parameters, you move on to step 3. If not, this indicates an intermittent failure. At this point, you should check the connections leading to the ECT sensor and the PCM for any signs of looseness or corrosion, as these often lead to communication failures. For the second troubleshooting step, you will again turn the ignition switch to the lock position 0 before proceeding. Next, it's necessary to disconnect the ECT Sensor 1's 2P connector for further testing. After disconnecting the sensor, turn the ignition switch back to the on position. You will again check the ECT sensor's data using the HDS. As before, you will want to verify if the readings are around 356 degrees Fahrenheit, 180 degrees Celsius or more, or if the readings reflect 0.08 volts or less. A reading fitting this description would lead you to proceed to Step 7. If the readings are normal, not meeting either condition, this suggests deeper issues, and you would advance to Step 11. In Step 3 of troubleshooting DTC P0117, start by turning the ignition switch to the lock position again. Next, you will need to jump the SCS Service Check System line using the HDS, which facilitates particular diagnostic capabilities. After jumping the line, disconnect connector C49P from the PCM. This step is crucial for isolating the ECT sensor from the PCM. Once you have done this, you will be positioned to check for continuity from the ECT sensor, 2P connector terminal number 2, to body ground. This continuity test helps confirm whether the wire between the ECT sensor and the PCM is intact, or if there is a short or disconnection causing the low voltage signal. In Step 4, you will check for continuity between the ECT Sensor 1 2P connector terminal number 2 and the body ground. Continuity indicates that electricity can flow properly through the wire. If you find continuity, it suggests that the wire isn't shorted and is functioning correctly. In this case, you will need to repair any shorts in the wire that may exist between the ECT sensor and the PCM connector C32. Repairs may involve splicing in new wire or re-securing connections. Following this repair, proceed to Step 13 for reconnection and final diagnostics. If no continuity exists, you will need to move on to Step 18 to diagnose different issues possibly affecting the circuit. Step 5 focuses on replacing the ECT sensor if prior steps indicated it to be defective. Start by turning the ignition switch to the lock position 0. Once this is complete, you'll proceed to replace the ECT sensor with a new or refurbished one. After replacing the sensor, it is essential to reconnect all previously disconnected connectors to ensure that the circuit is complete. This step is crucial for ensuring that any faults introduced by a defective ECT sensor are eliminated. After making all necessary connections, you will proceed to the next step of resetting the PCM to ensure it recognizes the new ECT sensor. The final troubleshooting step involves turning the ignition switch to the on position again. Once power is supplied, utilize the HDS to reset the PCM powertrain control module. This action allows the PCM to recalibrate and adapt to the new ECT sensor that has been installed. After resetting, it's important to perform a quick check by examining the ECT sensor data in the HDS to ensure that it operates within normal parameters again. Additionally, road testing the vehicle can further confirm if the check engine light is not illuminated and whether the system functions correctly. It's imperative to complete these final checks to assure that the repair has been successful and to restore reliable performance. Final repair verification for DTC P0117 is crucial to confirm that all repairs were successful. Start by checking the data for the ECT sensor using the HDS, ensuring that it now provides readings within the normal range. Make sure that there are no remaining diagnostic trouble codes, DTCs, stored in the system, which could indicate unresolved issues. A test drive of the Honda Odyssey should then be performed to validate proper engine performance. Check that there is no triggering of the check engine light during operation, and monitor for any abnormal engine behavior like overheating or poor fuel efficiency. A successful verification indicates that the repair process has effectively resolved the original issue. Preventive maintenance is an essential aspect of vehicle reliability, especially concerning critical components like the ECT sensor. Regular inspections should be conducted on the ECT sensor and its wiring to identify any signs of wear, corrosion, or loose connections before problems arise. Maintaining wire integrity is important to ensure that electrical signals are conveyed correctly to the PCM. After repairs, always remember to clear any DTCs to allow the onboard diagnostic system to recalibrate itself with the improved components. This routine can significantly minimize the risk of experiencing similar issues in the future. Implementing these practices will not only enhance engine performance, but will also prolong the lifespan of your Honda Odyssey. In conclusion, understanding the significance of DTC P0117, which signifies low voltage issues in the ECT sensor circuit, is vital for maintaining your Honda Odyssey's performance. By following the outlined troubleshooting steps systematically, you can effectively identify the root cause and perform necessary repairs. Ensuring that the ECT sensor and its connections are in good working order allows the engine management systems to function optimally, thereby enhancing fuel efficiency and reducing emissions. Additionally, performing regular preventive maintenance can further reduce the chances of encountering similar issues. Ultimately, adhering to these guidelines will lead to a more reliable and efficient vehicle, contributing to a better overall driving experience. Please like and subscribe to the channel. See you next time.